I'm going to briefly describe an interactive simulation that does an energy balance for filling a tank. So this is an unsteady state energy balance. And then I've shown you a couple snapshots of what this simulation will do. So in one case, we start out with an ideal gas, and we can adjust the temperature of the tank and the pressure. And then we have a feed line. We can also adjust the pressure and the temperature of that feed line. And what we're going to do is open this valve when we select play. This opens the valve, and then the button on the right resets. And then we can watch the result going to equilibrium of what's the final temperature in the tank when the pressure equals 15 bar. The tank is adiabatic, so there's no energy loss through the walls of the tank. And that's when we select ideal gas and we're looking at nitrogen. The other option is to select water, where now it's a little more complicated because we have a vapor liquid mixture, where now we can select the tank pressure, but when we select the tank pressure, the tank temperature is fixed because it's a vapor liquid mixture, and so this has to be saturation temperature. And so the idea is this gives us an understanding. If we look at an unsteady state energy balance, let's look at what that energy balance is that we're solving in this simulation. So the energy balance says that the final number of moles in the tank times the internal energy per mole of the contents minus the initial, and let's abbreviate it this way, initial number of moles in the tank times the initial internal energy is equal to the number of moles that flow into the tank, which of course is the difference between these two numbers, times the enthalpy of the feed stream here. So the enthalpy in is here, and then the internal energy initial here, and then the internal energy final here. This is the energy balance that the simulation solves. Let's go to the simulation and look at behavior. So here's the interactive simulation and set up for nitrogen. So the tank's at 200 degrees C, and we're feeding in nitrogen at 150 degrees C and higher pressure. And if we hit play and watch it go to equilibrium, the valve opens and then it closes once we get to 15 bar pressure. Notice the temperature is actually higher than either the feed temperature or the starting temperature as work is done on compressing the gas. And we can change the start, so we can reset, and then we can change our starting temperature and change our starting pressure as well as the line pressure and temperature. For the water case, now we have vapor liquid equilibrium, and so if we're feeding in superheated steam in this case, and again, if we, of course, the temperature goes up, go to the higher pressure, we have to be at the saturation temperature for 10 bar pressure, and we have vaporized some of the liquid as we've also raised the temperature and the pressure in the system. So hopefully by looking at how changing the variables affect things, get a better idea of this unsteady state energy balance for pressurizing a tank.